Well, good morning, everybody. Sorry, I'm a little sneezy this morning. Allergies here. Everything is blooming in Central California. Grace and peace to you from our Lord Jesus Christ and all the sneezy saints here in Central California. So I hope everybody's doing good this week. I had an interesting week, to say the least. I was on call this weekend, or on standby, as they say at the hospital. And I was just getting ready to cook dinner on Tuesday night. Threw a Trader Joe's lamb vindaloo in the microwave and I started cooking that. And I start hearing my phone start receiving work emails. It's got a special tone that I've come to recognize and hate. But I kept hearing the tone one right after another. Started getting work emails. And then they stopped. I thought, okay, good. And then I started hearing them again. And I looked at my wife and I said, boy, I hope I don't sit down to eat dinner and then I get a phone call. So I picked up the phone and started looking at the emails, and sure enough, they were coming in from my switches. That didn't bode well. So I started to eat my dinner as I was logging in on this laptop that I'm recording this on. I logged into work and started checking things out. And I'm seeing switches go online or switches go offline, come back online. So I thought, oh boy. So I started wolfing down my dinner, and then the phone rang right when I was about halfway through. And they say, hey, we lost the internet, and we're getting reports all over the hospital of things going down. Well, I was still connected by the internet, so I knew they hadn't lost it, but they thought they had. So said, okay, I'll check it out. So I checked it out, and sure enough, things were going on. So I called Extreme Networks and went ahead and got a case open for them to help me figure out what was going on in the network, because I couldn't see anything wrong. It should have been my first tip-off right there. Anyway, as the evening progressed, actually about 30 minutes into the call, my boss messaged me. I told her what was going on. She joined the call. She actually got our entire Extreme engineering team involved to help us figure out what was going on, because the poor GTAC person was kind of like deer in the headlights. So long story longer, I drove in, my boss drove in, and we spent the next next 8 hours at the hospital, trying to get everything back to normal. Basically, the entire hospital was down. The entire, users couldn't get anywhere. They couldn't get to the electronic medical records. They couldn't get out to the internet. Our wireless system wasn't working. Everything was down. And what ultimately happened was I used Intermapper, and I noticed there was one switch just way out on the edge there that was consistently down. It was consistently reporting something was down. So I ran out to that closet and just unplugged that switch, because by this time we were already starting to suspect a loop, but we couldn't figure out where the loop was. I suspected that switch, so I ran out there and unplugged it. And the loop didn't abate. What am I trying to say? So I ran to the next closet where that switch was plugged in. It was daisy chained off another switch. So I ran up to look at that switch, and then that's when I noticed something. So this is a stack of 2 switches, and when I say a stack, we have a way of taking 2 switches, put a stacking cable in between them, and then manage them as one switch. And I noticed that the bottom switch and the top switch both thought they were managers of the stack. Okay, things are starting to come together now. And I didn't realize it at the time. It was just after we were going back over this and thinking a little more clearly that the pieces started to add up. It appears that those 2 switches lost communication over the stacking ports. And so they both were claiming to be this particular switch. They're both claiming to be the master. And the way we connect these switches up is there's a fiber link from the first switch in the stack and a fiber link from the last switch in the stack. In this case, there are only 2 switches. And that fiber link is trunked together, bonded together, however you want to put it, by via LACP. So they're aggregated. Go back to the core, and it goes back to the core. The core is also a bonded switch. So there's a large chassis, bunch of bonding cables, and another large chassis, and you treat it all as one big switch. Those 2 fiber links will go from the top switch in the stack out in the closet, the last switch in the stack out into the closet, back over to the core, connect into one chassis, and the other fiber will connect into the other chassis. So from the core's point of view, it had 2 links going out to the same switch. Both switches were saying, you know, I am at this IP address, and this is my name, and this is my MAC. And the core was going, hey, we got a loop. So yeah, spanning tree, broadcast storm, boom. Spanning tree is apparently not set up correctly on the core, even though it's been running for years. So anyway, that's the long sad tale, is after getting called into work at 6 p.m., I finally got to leave at 3 a.m. So that's part of the fun of being on call as a network administrator. The only good news is it's been quite a while since I was called into work like that. So that's not a frequent event. But anyway, so we got it all ironed out. It took a long time to bring everything back. I don't know why, but it did. So it started getting me to think about, well, how can we locate loops a lot quicker? And if we get it down to a certain switch, how can we locate a loop? Now in that particular situation, that was pretty uncommon. I mean, that's not going to happen that often. And frankly, between those 2 switches, there should have been 2 redundant stacking cables, and there was only 1. So if we had had 2, this never would have happened, because the second data path would have been there between the switches. You know, even if it lost communication between one stacking port between the 2 switches, more than likely we would not have lost both. It's not a guarantee, but more than likely. And we're still trying to figure out who disconnected the other stacking cable and where it is. Be that as it may. So what I did here, I'm gonna grab this. No, I better do this. I'm gonna grab this switch. I brought a little homework home. So I brought home this little, it's an X440 G2 12-port model. And just this little tiny switch that I could grab and throw in the truck and bring home with me. And that's not the type of switch that was being used that failed, but it's same command sets. It's close enough. And it will go back to work this weekend, because I don't want any of this stuff at home. I like home to be home. So anyway, I started playing around with this thing and trying to simulate loops. So what I'm going to do is share my screen and then have a seat so that I can show you what I did here. Okay, let's just share that screen. There we go. All right, let me grab my super comfy chair here. Step stool. Yeah, my garage is plush. There we go. So I thought, well, hey, why don't we see what a loop looks like? So I've got a Cat5 cable there plugged into port 2. And I'm going to plug the other end of it into port 1. But let's take a look at the switch first. Let's see what's going on. Let me get my little script here. There's my script. Around so I can see everything. Okay. So first thing I'll do is we'll just take a look at the ports. What's going on? What do we see? So right now, there's nothing there. You can see on port 8, that's where my laptop is plugged in. It's on the switch, so the laptop's not talking anything. It doesn't have an IP address. It's just there to have something plugged in. So where's the counters? Or what? What can we see? Let's look at utilization. See, there's not a whole lot going on. Utilization is very, very, very low. This would show up as like a percentage. You know, you'd see how many packets. Actually, it's not. That's not the one that shows up as a percentage. I think this one is. There we go. Sorry about that. You can see there's nothing going on. So let's make something happen. So I'm going to plug port 2 of the switch into port 1. Let's see if we can see anything happen. So let's just show ports here so we can see when it happens. Right. So you can say, why would anybody do that? So now you can see port 2 and port 1 just became active. Why indeed would anyone do that? So another quick short story. This one will be short. We got called out to our call center, a little remote site, I don't know, about a 15-minute drive from where I normally work. And they said their phones were going up and down. So we go out there, and my boss came with me because she was still relatively new. She said, "This sounds like a loop." A loop. That's how she says it. So we did our best. We kind of hunted around, and actually she found it. Somebody had seen a empty Cat5 cable just laying on the floor. So being telephone operators, they thought, well, that's not right. So they plugged it in to the nearest port. What they didn't know is that the other end of that cable was already plugged into a port. And they created a loop. So they created this exact condition that we're seeing right here. So, okay, that's, they're plugged in, but you know, the switch is still updating. Everything looks normal, right? Well, if I was, let's say I had another computer on here and I was trying to ping it, we would see that the pings would become very spotty. And you can see that right here. Let's see. How much of the bandwidth on those ports are being used? No, not a whole lot yet. So we're still in pretty good shape. Okay, you can see 7%, it's starting to come up. Let's just keep an eye on it. Uh-oh, oh, look at there. So you can see my laptop there on port 8 is 18%. That's kind of a lot too. But still nowhere near the 100% you can see on ports 1 and 2. 100% of the bandwidth. Let's look at this port utilization. There's the bytes and so transmitting and receiving packets per second. 973,000 packets per second are being transmitted. That's not packets total, that's per second. Every second that ticks by. As quickly as it takes me to say 972,000, that's how many packets it's sent. That's quite a bit. Let's see, what's another command we can do here? How about show port statistics? Look at that. This is the total bytes transmitted. And you can see, you know, port 8 where my laptop is, it's no slouch. He's transmitting quite a bit. But wow, look at that. So if you have a Cisco, you'd have to like think what are similar commands I could use. Extreme, this is what we would use. Show port statistics, show port utilization. Yeah, that's so if I was looking at a regular switch, I would certainly see lots of high packet counts on the other ports, but that greater than 999,000 would jump out at you right away. And especially here, the show port utilization bandwidth, that would jump out at you. Because you can see port 8 is, it's still transmitting quite a bit, but its received bandwidth isn't anything. But the other two ports, 100%, 100%. So now imagine that being transmitted out the uplinks as well, because that's what would be happening. So all the uplinks, the uplink from this switch would become clogged. It would get up to the core. So what's happening is spanning tree or the switch is sending out hundreds and hundreds of thousands and thousands of bridge protocol data units, BPDUs. And I won't get in too deep on spanning tree because I'm not that well versed on it myself. But that's what it does. It uses BPDUs to send out updates, switch topology updates. And basically, it's updating itself over and over and over and over again. And then it would be spewing it out the uplink ports if they're there. So what if you don't have these commands? What could you do? Well, if you could fire up Wireshark. Let me share Wireshark as well. Let me share the whole screen here briefly. So you could crank up Wireshark. And there it's going to be grabbing a bunch of stuff. Well, what do I look at? What you could do is come up here to statistics and just look at the conversations. And 3C8F. Let's see which one that is. I don't think that's my laptop, is it? Okay, yeah, that's the laptop. It's not showing up yet, but in a minute, what you would see is another MAC address show up here. And over time, you'll start seeing more packets and bytes coming from it, which my little demo here isn't cooperating, but that's what would happen. So you can see my laptop's just broadcasting. But if you watch these conversations long enough, soon you'll start seeing another MAC address show up, and the number of packets and bytes will easily surpass what you're seeing here, and that'll be the switch that's generating all the broadcasts and probably has the loop. So since that's not going to cooperate, we're not going to waste time there. If you can, grab a switch on your own and try it, and see if you can duplicate that. Actually, I don't want to save that. I don't really care about that. So let's go back. I just want to share just that one screen again. Hang on, bear with me. Hello again. And let's just share this guy, just to keep it clean. There we go. So this is happening, but oh, here we can do one other thing. Show spanning tree S0. You can see spanning tree is disabled right now. So this would be just going nuts out over the network. You can see ports 1 and 2 are forwarding traffic, just spewing traffic. So the quickest and easiest way in the extreme world, probably the Cisco world, to rectify this problem would be just enable spanning tree. So let's just take a look at that bandwidth one last time. Okay, 100, 100, 100. All right, let's enable spanning tree. This is how you do it on extreme. Enable STPD, spanning tree daemon, as 0. If I can do that right. Spanning tree protocol daemon. There we go, as 0. I get those backwards all the time. I don't know why that is. All right, let's give it a second and let's look at the bandwidth again. Give it a second. Actually, let's look at the ports. Okay, now you can see that it's decided to block one of those ports, but because it's a redundant path. So let's go here and look at the bandwidth again. Starting to drop off. They're starting to come back to normal here. Keep taking a look and look at that. Receive bandwidth and transmit bandwidth went down from 100%, 74%, now down to 0%. This is just this is the peak. This is what it was. So just by enabling, sorry, my daughter is leaving. Just by enabling spanning tree, we've stopped that in its tracks. But we still, and you know, we can see what ports it was. But beyond enabling spanning tree, what I do in my network is I enable a feature called the edge safeguard, and I block BPDUs at the edge, which means if somebody plugs in a switch, it's not going to be able to exchange switch updates with people. And what's more, if one of my ports senses that somebody has plugged in a little mini switch or something like that, it's going to disable the port. So there, because I don't want mini hubs or mini switches out there on my network. So how do I do that? With mini hubs, you'd have to limit the MAC addresses to like 2, which you can do. With the extreme, you can enable MAC locking. With this, what I do is I enable, what's the command again? Sorry, I've got a cheat sheet over here that I use. So one of the things I do after enabling spanning tree protocols is I bind it on all the VLANs that are on the switch. So I use this command. And the reason I do that is because Extreme told me to. So when we moved from our legacy Extreme to the newer Exos Extreme, I asked them, what are the best practices with setting up spanning tree? And this is one of the commands they gave me. So you enable it on per VLAN, number 1. Number 2, and this is the part I was just talking about, what I do is I enable this on all my ports. And I'm going to add, a spider just tried to crawl up my hand. I'm going to add one other little command here. Oops, sorry, I didn't copy it. Let's go back. This isn't perfect. I'm not a professional YouTube personality. So there you go. So what I'm going to do is add my ports to spanning tree. This is only a 12-port switch. Actually, I'm sorry, it's a 16-port switch. 1 through 12 are designed to be edge ports. 13, 14, 15, 16 are designed to be uplink ports. But you can use them for edge ports. It's up to you. So I'm telling the spanning tree, okay, my edge ports are going to be 1 through 12. I want you to enable edge safeguard, which means turn it off if you see Actually, Edge Safeguard, no, Edge Safeguard is the one that tells it that, okay, this port type is actually an edge type port. Bpdu Restrict is the one that says if you see a switch, sorry, I keep looking over at the switch there. If you see a switch plugged in or something, anything on this port that's sending BPDUs, disable the port. And recovery timeout is something that you add. I wouldn't normally add it. I would leave it as the default. I'm adding recovery timeout right now, 60 seconds, just for demo purposes of this video. So let's go ahead and do that. So now, oops, I forgot to unplug the cable before I did that. Shoot, oh well. Let's go ahead and look at show port status. Show ports. That's the legacy command. So you can see, I jumped ahead of myself, so I gotta wait a second. Gotta wait a minute, actually. So you can see I left that port, those two ports plugged into each other, and they're already disabled because I entered that command without unplugging that cable first. So no, that's okay. You have to sit here and listen to me talk for another 30 seconds or so. And, but the good thing is you'll see that the recovery timeout feature in action right now. So I won't have to show you that later. So in just a minute here, you are going to see ports 1 and 2 go to enabled state. So you see the D's turned to E's. So there you go. So the other thing I want to do is show port 6. The thing I want to do is I want to zero all these out. It's cool. You just press the number 0 and it zeroes all those out. So, okay. So the only thing generating traffic out there right now is my laptop on port 8. And it's still trying to find a DHCP server. And you ain't gonna. All right. So Joe user comes along. Says, hey, there's a cable unplugged. That's not right. So I plug it in. It still did it too quick. So let me unplug it again. One more time. Sorry, I know. This dude's lame. I know I'm lame. I don't know why you guys watch. So we're going to do this one more time. You get to see the recovery timeout feature in action one more time. What I wanted to do is have this part going so you can see where it connects, when it's connected, and how quickly it actually gets disconnected, which you can, or I mean, I shouldn't even have to show you. You can see it was pretty quick. So as soon as I leaned over to plug that in, it was boom, it was disabled. So if somebody, you know, connected a looped cable on your network, it would be disabled just that quick. So, and you won't have to worry about increasing byte counts like I just was. You know, we'll go through and look at the statistics command. Okay, there we go. So you guys keep watching that. You see, I'm gonna plug this in. You're gonna see, you know, it become abled. You're gonna see link speed actual, duplex actual. And then you'll just see it all go away, and these two E's that you see somewhere over there are going to turn to D's. Just that quick. So they're plugged in, they're enabled, and boom. You know, I'm consoled in. You couldn't even see it. It happened so quickly you couldn't even see it update. So sorry I made you go through all that. Get out of here. Let's look at the port utilization, the bandwidth. Yeah, there's nothing to see. Let's just look at regular old port utilization. There's nothing to see because that port was disabled. The loop never happened. Somebody plugs into a switch. Somebody plugs a mini hub into your switch. You don't want it out there, you don't have to worry about it because it's it's not going to go anywhere. And you're going to get a call that says, hey, my computer's off the net. And you'll say, okay, what's your IP address? And you'll try to find their IP address. You won't be able to. So you'll walk out there and you'll check their cable and you'll see it's plugged into a mini hub, and you'll be able to shake your head and shake your finger at them and say, don't use mini hubs, mini switches. So anyway, that's the long sad tale there. That's what happened to me this week. And this is what I've been doing, trying to brush up on. So to rectify that problem that we ran into this week, I'm going to go in early Monday morning, power down that switch, connect up 2 stacking cables the correct way, and power it back on, and then we should never have to worry about that switch again. So there you go. Anyway, this video went way longer than I meant it to. Thanks for sitting in there. Thanks for hanging in there. And as always, I do appreciate you guys watching. I do appreciate the subscriptions and the likes and the shares and most of the comments. You know, the ones that leave a comment just to tell me how stupid I am. You guys are stupid. So I honestly, I just delete your comments. So if you're just going to do that, that's, you know, it's fine. But you're wasting everybody's time. So, you know, just if you don't like the videos, just move on. Honestly, come on. And if you do like the videos, that's wonderful. You know, don't feel like you got to sit through them all the time. This is just something I do to try to help, you know, 1 or 2 people out there, whoever finds any kind of help or inspiration from it. You know, that's why I do it. And one other feature I want to implement is prayer requests. So I do pray every day. And if you have a prayer request, I mean, a lot of people ask me, how do I get a job? Honestly, today's climate, I don't know. I don't know how you're going to get a job doing this. But I know it can be done because I've done it. And maybe that's your prayer request. But I know God is sovereign, and I know Jesus is powerful, and he's still at work even today. So, prayer works. You know, prayer does work. Intercessory prayer. Somebody praying for God to intercede on your behalf works. So send me your prayer requests if you got nothing else better to say. So as always, thanks for watching. Click the subscribe button and like and notification bell if you so desire. And we'll catch y'all next time. God bless everybody. And for all